It's time for you to exercise the skills you have learned. Your challenge is to develop an AI classifier from scratch, working with a new dataset. We'll be using the CFAR10 dataset, a collection of 60,000 32 by 32 pixel color images in 10 different classes, including airplanes, cars, birds, and cats. Like the datasets you've used previously, CFAR10 is in common use in the AI community owing to its balance of simplicity and complexity, making it perfect for our final project. Lots of people have used it, so there will be plenty of people to reach out to and discuss any problems you may have, which is a great way of getting into the wider AI community. You can download the dataset directly from frameworks such as PyTorch, where it's included as a standard dataset. Once you've downloaded it, it should be split into 50,000 training images and 10,000 testing images. We've given you some starter code for this in the skills section. As you begin this project, remember the techniques we've covered in earlier modules. For example, consider using a convolutional neural network, which can be particularly effective for image classification tasks. You could also explore data augmentation techniques, such as flipping or rotating images, or adding noise to them, to increase the variability of your training data, helping your model generalize better to new, unseen images, although this shouldn't really be needed here. When designing your model, think about the importance of regularization to avoid overfitting, especially as the dataset you'll be working with is relatively small in terms of image size. Techniques such as dropout or level 2 regularization could be crucial in ensuring that your model performs well on the test set. What do you think? As you train and validate your model, keep an eye on metrics such as accuracy and loss to gauge how well your model is learning. But don't forget to evaluate your model's performance on the test set after training. This will give you a clear indication of how well your model can generalize to new data. You'd probably want a confusion matrix of some form while developing. And don't forget that you can't just keep repeating things. You'll need to reset your runtime to get back to a fresh starting model. This project is designed to be challenging, but also rewarding. You'll need to apply everything you've learned from data processing, model architecture, training, and evaluation. But remember, this is your chance to experiment and learn. Don't be afraid to try different approaches and see what works best. By the end of this Capstone project, you'll have a fully functioning AI classifier that you've built from scratch. This not only demonstrates your ability to solve real-world problems using AI, but also serves as a strong portfolio piece for your future endeavors.